Hello, welcome to the Data Channel. As part of the Databricks Certified Machine Learning Engineer Associate Certification course, so we are bringing up the next video that is about data preparation and feature engineering. So almost 80% of the time, what happens is the data that you are getting is not fit for the purpose, right? That means it is not clean or it is not fit for performing the machine learning activities, right? So you need to perform certain treatment. So it might be the data cleansing part of it, right? Or it might be handling missing values or performing a feature selection, a feature performing feature engineering. So all of these topics come under data preparation and feature engineering. And so this is more about the fundamentals of it, and this particular video is more of a theoretical. So we would recommend you to please watch this video till end of this video, so that you will get maximum out of it. So this is more of a theoretical video. Please take notes, pause and take the notes where and when it is required. Okay. So before proceeding, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So now, as part of this course instructions, would be definitely wanting you to please pause and take notes. And so these instructions are quite important to be followed in all of these videos in this playlist. And also make sure you adjust the volumes according to your learning speed. My way of teaching would be slower or faster for depending on the different people, right? So adjust your volume and speed accordingly, and also watch the full video and all the entire playlist in the videos in the entire playlist, so that you get maximum out of this course. And another important thing is practice along wherever there is a lab sessions. So there will be definitely a lab session followed by every theoretical sessions. So in that, please follow through and practice along with me, so that get a hands-on experience, right? And feel free to comment in the comment section any queries, any suggestions. And also, if you need the practice notebook, please mention the course name and like send the email to the email ID in the description. So you'll be able to share the practice notes so that you can practice yourself. So with that, we will get started with the agenda of this particular module. So this module is more of a data preparation and feature engineering, right? And in this, we'll be promptly learning how to prepare the data for machine learning, because 80% of the time that we'll be spending is more of preparing the data, right? And 20% time is actually you are spending to create models, like machine learning models, and train the data, etc. So most of the time, that is 80% of the time almost, will be spent in preparing the data, making sure you split it into different machine learning tasks, including train, test, hold strategies, and cross validations. And also you learn about handling the missing values, and how do you handle missing data values effectively, and also recognize the role of indicator variables, and also apply different encoding methods, manage categorical features while balancing the efficiency and potential risks. And also we'll understand the advantages of feature standardization and identifying challenges in interpreting the results. So overall, the objective would be like end to end. You need be if you follow this end to end playlist, and this particular module is if you complete this module, so you'll be able to design a end to end machine learning pipeline, data pipeline, design and create a pipeline for data imputation and transformation that works across various data sets, and also create a advanced feature engineering pipeline and implement a method to store it for feature reuse. So that is the whole objective, so that you become, it's not just about learning the machine learning theoretically, but practically you are creating the end-to-end pipelines and also making it operational, right? So that's the whole agenda of this particular module. So we will get started now with this understanding of why clean data, because the data available for you would be in different formats, the quality of data would be different, and as I said, 80% of the time the data you have might not be fit for the purpose. Why it is so? Because you get the data, like it might be transaction data, it might be unstructured data, it might be data coming from different IoT devices, But what happens usually is the data comes with a noise, the data comes with the missing values, right? And data is represented in different ways, and it comes with the different data types. So ideally, when you are talking about machine learning, so machine learning models works on the good data. That means it has to understand, the machine learning models has to understand the data first thing. Second thing is, the more the quality of the data, more the performance of the model that your machine learning model you are creating. Because if the data quality is bad, or the data is having a lot of missing values, etc., so then you cannot expect the more accurate machine learning models or accurate results. So that is why it is very important to have the clean data. Otherwise, if you have a garbage data, you will get the very unreliable model. So that is why it is important to have the clean data with less missing values, and having the categorical values defined, so that machine learning can easily understand, right? And you might be thinking, what is clean data? So what is clean data in the sense, first of all, you need to see the data and understand if there is any missing values. So if there is a small number of missing values, you need to impute the missing values. You need to perform the encoding so that the machine learning understands, because machine learning algorithms usually understand the categorical values in terms of some integers, some ranges, right? You don't usually understand the strings or the descriptions kind of things, right? So that is why it is you need to clean the data in such a way that it will suit for the model that you are planning to create for, right? So that is why that is a clean data. So, and clean data also should be like, the definition of clean data is it should be accurate, complete, right? And also it should not mislead. Sometimes there will be a lot of outliers in the data, so you should think of getting rid of those outliers data, so that your machine learning model will not get deviated because of that outliers data. So all of this will contribute to the data quality. It might be noise, it might be outlier, it might be the missing values, right? So all these will contribute to the different factors of the data quality, right? Accuracy, like timeliness, and getting the data at the right time is also very important. And valid data, you need to get the valid data, accurate data, right? So these are all the contribute to the data quality aspect of it. So with this, we understood what is clean data and why we need a clean data, right? With that, we will see like cleaning and formatting data. What exactly we're talking about here, the cleaning and formatting the data. So first we'll discuss about the handling missing values. What exactly handling missing value is? You need to impute whether you take a mean, median, mode, or like some kind of a KNN imputation, or drop the values depending on the context. Sometimes you cannot really handle the missing values because they might not be contributor for the machine learning models, or it might be misleading the machine learning model. So in that case, you might need to drop those values also. Or generally, what you will do is you impute the values with the mean, median, or KNN imputation, or different imputation mechanisms that you have. And also there is a something called as remove duplication. So duplications also can cause a lot of disturbance to the machine learning models when it is getting trained. So that's it is important to ensure no repeated rows or IDs based on the primary keys, or anything that identifies uniqueness. So that should be taken care of, and anything which is considered as a duplicate records, that need to be completely removed. And next you have a outlier treatment. So what that means is, so you need to there are different statistical methods like z-score, IQR, or ML based methods. So to detect the outlier, and understanding those outliers, you need to treat those outliers, because otherwise again it can mislead the data machine learning models. So next is the standardizing the format, which is also important, where you convert for example, you have a date column, you have categorical values, numerical precisions, or string values. So in that case, you need to standardize those particular formats, right? Date formats should be all the date columns should be standardized to a particular format, right? So, and you have a categorical value, enum values. So you need to standardize those values. And next is you have the data type conversions. So different data types can also contribute to the quality of the model that you are building, because you cannot treat like amount value as an integer, right? It should be double, right? And different like how do you define a type, right? So there will be a string value, string variable. So you cannot consider the string variable as integer. So if you make it as integer, so essentially you're losing the data, and you need to take care of null values if there is any null values. So how do you kind of treat those null values, right? And so ensure there is a correct types, for example, integer, float, date, time, categories. So all these types should be you need to perform some kind of a type conversions or casting, so to make them to bring to that required format. And finally, you have normalization or scaling, so which is nothing but applying min-max scaling, standardizing the values, or robust scaling for numerical features. So this is basically the concept of cleaning and formatting the data. So it is not, there is no thumb of rule in any machine learning that you have to perform these operations. It completely depend on the exploratory analysis that you'll be doing with the data. So here, but these are the key features or the key considerations you need to take when you're talking about cleaning and formatting the data. So this is a very first step that we'll be doing in machine learning. So the models or training the data will come at the end, but here we are talking what is very critical, that is of cleaning and formatting the data, because this is what decides the quality of the model that you're building. So moving on, you have something called as feature engineering. So feature engineering is also equally important than cleaning, data cleansing, and whatever the data cleansing operations that we did in the previous slide we were talking about. So feature engineering is also, the purpose of feature engineering is also to make the data suitable for machine learning model that you will be creating in the next steps, right? So here we're talking about encoding categorical variables. What that means is there is different encoding methods. Again, one hot encoding, label encoding, target encoding, right? So you take those encoding methods. So you treat the different columns. There will be different columns, right? So each columns, there is nothing like, again, one thumb of rule that you have to apply particular encoding technique for a column. So it is you have to decide which encoding technique I have to apply for a particular column, so that that will be suitable that will be suitable for making it ready for the machine learning use cases. And there's something called as derived feature and transformation. So that means it's like creating a new variable. For example, day since sign up. So you are creating a derived variable, so or purchase frequency. So you basically count the number of transactions that a customer is making, and you create a new column called purchase frequency. So those are the derived features that can be built, so that it will benefit for the machine learning use cases. For example, you can take a age, right? So instead of having a date of birth, you can have a column called age. So that is a derived column from the date of birth column. So that will also help you in the machine learning use cases. And there is something called as binning. So binning is nothing but there's a group continuous variable into a ranges. So for example, you arrange 0 to 10 age people into one bucket, and 10 to 20 into second bucket, 20 to 30 into third bucket. So that is a range, right? And you might bin students based on the score that they are making, right? So 1 to 30, you can bin them into first bucket, and 30 to 60, you can bin into second bucket, etc. So it's about binning is more of a grouping the continuous variables. So you are converting the continuous variables into the range, okay? Because continuous variables might not be really contributing to the machine learning analysis that you're doing or models that you're creating. So you bin them so that you categorize them, and so the categories can be used for machine learning use cases. And you have feature interactions. So this is nothing but polynomial features, ratios, differences, and or domain-specific interactions. So you can perform using that. And there is something called as dimensionality reduction. So this is one of the um, most frequently used or most popular feature engineering, that is a PCA, principal component analysis, that we'll be discussing in the upcoming videos. But this is the most important or one of the most discussed topics in feature engineering, that is especially for dimensionality reduction. And along with you have autoencoders when dealing with the high dimensional data, and you have text features, you have time series features. So it depends on, again, data, how you have the data, and what exactly you want to do with that data, right? And if you talk about examples, right? So for examples for cleaning the data, you can take handling missing values. Suppose there is a age with a median or drop. So median or drop the row with greater than 50% missing. So that is something missing values. That is how you can handle the missing values. And if there is a duplicate customer IDs, you can remove those rows. And outlier treatment is nothing but you cap the salary above the 99 percentile. And standardizing the format again, so you have the y by mmdd format for the date formats. You can standardize those. And the data types also, like price, there would be $5,000 as a price. You can convert that to numeric by removing the dollar symbol. And there is examples of cleaning and formatting the data. And if you talk about feature engineering example, suppose there is a city column, like a city column might be Delhi, Mumbai, etc. So you can use one-hot encoding to kind of give those values, basically categorical value or numeric value for Delhi, Mumbai, Bangalore, etc. And you talk about derived features. So you can use day since last login. Okay. So that you can derive using today minus last login date. So you can get what is the day since last login of a particular customer, so that you can send certain promotions to the customers. You can target those customers to perform certain use cases. And binning is, again, as I was telling, 0 to 18 you can mark it as one category, 19 to 35 you can mark it as second category. So it's more about bucketing those continuous values. And feature interactions is nothing but it is again a transformed version. So you can transform or you can extract a feature basically out of existing columns that you already have. Like, so for example, using weight and height, you can extract a feature called BMI, body mass index, right? And you can also have performed the principal component analysis on 500 text features and perform a dimensionality reduction using that. So similarly, you can perform a time series analysis by creating sales last 7 days average on a rolling mean, as a rolling mean, etc. So these are the examples, right? So what we discussed is as part of the feature engineering. So we discussed cleaning and formatting the data, and also we discussed feature engineering. So these are the two important concepts in data preparation and feature engineering, right? So these are the first steps. Okay. And why we did it? So the reason why we did it is, the answer is simple. So the way we make the data will to make it model friendly, right? So the whole purpose of doing this operations or creation of this data or modifying this data is to make the data as a model friendly. What that means is, as we discussed, if model has to create a robust, accurate kind of a result, right? If that has to happen, so then the data that you are giving should be of having less missing values, right? And the clean data without any outliers, and you convert those string values into encoded values, etc. So that is where you need to perform this step, which is very critical and very important. So next we will move to something called as feature extraction. So feature extraction is a subset of feature engineering. So this is nothing but what you are doing is, here you are deriving the useful representation from the raw data. So here you see the raw data, right? The raw data is an image, right? From this image, you are deriving some meaningful insights. So you might be extracting the features like eyes, nose, mouth. What are the what are the feature of out of that you are extracting that. So it might be coming from a text here. We have taken example to show the representation, but it can be audio, video, high dimensional data, text data, right? So from the text, like it might be a paragraph of a story. So you want to extract certain feature. You want to like segregate the data which constitute to different genres using those particular paragraph. So that is a feature extraction. So here the feature extraction is nothing but you are extracting a different um, organs, right, based on the image that you are having. So that is what about the feature extraction. So it might be, you can take example of text data. So and as I said, like you can take a novel and you can convert those words into different buckets of different genres where that fit into, or emotions where that fit into. And images, we can perform some edge detection. So here what is happening is edge detection is happening. Okay, and there's different color histograms and texture features. Based on that you're categorizing, right? And if it is audio, so it depends on whether it is an image, audio, video, or time series data. So based on that, you apply different algorithms. So like, so for example, if it is audio data, you use mel frequency sepstral coefficients. So that's MFCCS. So that's audio data for performing the feature extraction from the audio data, or you can use spectrogram features, etc. If it is image data, so you can use the edge detection, you can use pixel intensity histograms, color histograms, or text features. Or if it is a time series data, you can use Fourier transform for frequency component, or wavelet transforms, right? It depends on what kind of data again. Okay. So this is what we call it as a feature extraction. So now we will see what exactly the benefits of feature extractions, right? So first thing is dimensional reduction. That means it converts high dimensions. What is high dimensions? Like say for example, you have image, text, or time series data. So those you are breaking into a smaller chunks, right? Or a meaningful representation, because you see a map, right? And in that map, you need to identify and divide first you divide the continent, countries, right? And then you divide into states, regions, and then capital cities. So basically you are identifying the capital city of each country or a state. So you are performing the dimensionality reduction. So you got a bigger image, the world map. So from that word map, you are trying to drill down to a dimension to extract the capital cities of each states. Okay, so that is what you are talking about, dimensionality reduction. You are taking a bigger picture and you are breaking down into multiple chunks, right? And so there might be an image, we're talking about 10,000 pixels. And in that 10,000 pixels, what might be useful is only 100 pixels, because you want to perform the emotion of a particular person. So if to perform an emotion of a particular person, you just need few features. For example, eye sides and cheeks, maybe lips or nose. So rest all body parts images might not be required for performing the model, or they might not contribute to the model. So that is why you concentrate or target only those particular dimensions and reduce the dimensions to the targeted features. So next you talk about the improving the model performance. So feature engineers also improve the model performance. Why it improves the model performance? Because you are removing the noise, unnecessary features you are removing that is not required, and you keep the most informative part of the data. And so that is why it's boost the accuracy and the generalization. Okay. So then you're talking about overfitting. Okay, so overfitting is one of the major problem. So what is overfitting is, for example, there is a model which you are training the model with a similar data every time. So what it happens is, because you are training the model with a similar data, it memorizes the data rather than learning from the data. So with that, what happens is, it kind of overfits. So whenever you're giving the completely new set of data, it will not be able to predict, or it will not be able to perform better. So that is one of the problem. So that problem will be reduced here. Why it will be reduced is, by focusing on essential features, models are less likely to learn the irrelevant patterns. So there is a irrelevancy will be less. So here, because we are targeting, and also it speeds up the training and inference because there is a fewer input features, so less computation and faster ML pipelines. And it also handles the unstructured data because, when the raw data comes in, so it makes the raw data like text, images, and audio usable for machine learning. Because usually these kind of data, whether it is an image, audio, video, so this will not be directly usable for machine learning use cases, right? You need to perform some kind of feature engineering or feature extraction from that particular data. So then you can perform some kind of a meaningful machine learning use cases out of it, right? For example, extracting MFCCs, based like technique from the audio, which enables a speech recognitions, right? And you have a better data visualization and interpretation, because there's a low dimensional extraction features, right? So that this will help visualize the clusters and relationships. And also it enables the transfer learning. So what that means is extracted embedding from pre-trained models. There are different pre-trained models like BERT, ResNet, etc. can be reused across tasks, saving time and resources. So, if you take a summary out of it, what exactly this the extraction, feature extraction, that it is, these are the benefits of feature extraction. You basically extract some only the required uh, the area, subject area from a large chunk of dimension. So you are reducing the data into the targeted data. Suppose you want to learn about cancer cells. So what you generally do is you take a lot of images and videos, etc. But what exactly you're doing is you're concentrating on T cells. So cancer works on T cells, right? So you need to concentrate only about the T cells. First thing is you need to identify where are the possible T cells, right? So only those images or videos you have to kind of target and extract the data from that audio or videos, video or images that you are having, so that you get the extraction of only the T cells. So that is where because you are extracting only the part of the image or video where the possibility of T cells exist. So the accuracy of the model will definitely increase, and it will not bias the data, bias the learning, or bias the model with the inaccuracy because of a certain noise, etc. Right? So that is the whole purpose of feature extraction here. So if you see, next is feature selection. So we already talked about feature extraction. So next is feature selection. So this is a process of choosing the most relevant features, right? Suppose we talked about like T cells, we are talking about cancer cells. So we might identify that there are different parts where you can extract the T cells. That is identification of that is a feature extraction. But after that extraction, you need to select. So that is also a process that is called as feature selection. So you're choosing the most relevant feature or variable from the data set. So which variable can contribute to your model? So that is where you are learning here, and removing the redundant or irrelevant ones from the training model. So this actually what it does is this improves the accuracy and reduces the overfitting and makes the model faster and easier to interpret. So basically there are different types here. One is the filter method where you talk about a statistical test. So here you use correlation, chi-square, ANOVA or mutual information to select features. For example, in a customer churn data set, if the customer ID has no correlation with the churn, so then there is no point of having the data. You can straightforward drop the data, right? So that is where you're talking about filtering method. So you're removing the data straight away, or you can keep the data. So both is done in this method. And the second method is wrapper method, so which is more of a model based. So here it's an iterative process where it selects the subset of the feature. So because the feature extraction is done, so out of that features, so model will try to run multiple times iteratively to identify which is the better feature for it to consider for the machine learning use case. It will try. It is a trial and error basis, right? So it'll recursively feature elimination. There's something called as recursive feature elimination (RFE) with the logistic regression. It picks up the top predictors of a lone default, for example. So next type is embedded method, where it talk about built into models. So that means there are few feature selections happening during model training itself. So this is the last step. So during the model training itself, so this particular algorithms work when we are talking about the model training itself, the last step itself. So here also there is something called as lasso regression, L1 regularization. So it shrinks the coefficient of less important variables to zero. This is on the fly when the model is getting trained. So this all the embedded methods would be operating and selecting the features that is required for its model. For example, random forest feature importance ranking like highlights to top driven of churn. Okay. So if we talk about one more example, I want to give, suppose you are having a prediction of house prices. So like house prices depends on area, number of bedrooms, number of bathrooms you have, how old the house is, right? And there might be different attributes like house ID, owner, like owner name, etc., right? But so house ID and owner, for example, right? So these might not be required. You can drop this. House ID and owner name doesn't contribute to the identifying or predicting the house prices. So you can straightforward drop those. But area, number of bedrooms, like age of the building, etc. So this will definitely contribute to the models. So those you can keep it. Right. And the key difference between the feature engineering that we saw and the feature extraction is feature engineering is creating a new features. So here feature selection, what we are doing is we are picking the best feature and discard the rest. Okay. And the feature extraction is more of transforming raw data into features, where we are doing a principal component analysis and embeddings. So now we will go to model evaluation. So model evaluation is more of evaluating the model. So it's a next step basically. So once you have the clean data, you got the data from different sources, you cleanse the data imputed, you did a feature extraction, selection, feature engineering, all these steps, right? So now we are moving close to the model creation. So when you go towards model creation, first you need to evaluate the data that you are using. Okay. So why we need to do that is so if the one of the important thing here we are doing is data split, because when you are machine learning is more of training the models with a different data set. So data set is the main critical input that you are giving. The parameters that you are passing to the model will derive the efficiency, accuracy of the model, right? So to perform that, so the data is a critical element. So the data that you are using, so it needs to be having the data split. So we perform something called as data split. Suppose you have 10,000 rows, okay, or 1 million rows. So you cannot use 1 million rows to straightforward and do the machine learning training, etc. Right? So you need to split the data. Why we need to split the data? Because there might be something called as overfit. Okay. So when we are building a machine learning model, so we split this data into different types. Like one is training data, you need to have validation, you need to have test set. So you need to split the data into three different category. So that why we need to do that, we will to make sure the model learns and as well as generalizes the unseen data. Because if you put everything in one bucket and you give the data, so when you are giving new data, it might be completely we might not have to we might not able to test the efficiency of it, right? So that is why we keep the data divide the data into multiple chunks. So first we train the data, with some sort of data, and then you give some other subset of the data and see whatever you're expecting, can you validate with that expectation whether it is meeting your expectation. So if it is giving the good percentage of accuracy, so then you go for the next, where you talk about test set. So finally it is like a final test, so you give the test set, so again you test the accuracy of the model. So if it is giving good accuracy, so then you can conclude that the model that you have chosen is suitable for the use case. So again, data split overfitting. So it avoids the overfitting, because if you train and test the data on the same data, the model may just memorize the pattern rather than kind of creating a actual model. Okay, and it might be splitting, and splitting ensures we check the performance on the unseen data, because if you keep the data for testing or validation, so that is unseen data, right? So that you can use it for evaluating evaluating that. And next you have evaluate generalization. So that is nothing but a test set simulates the real world data, help ensure the model works outside the training example. Okay. And there is something called as hyperparameter tuning. So this is the validations setup, where it helps the pick the best parameters. For example, learning rate, tree depth, without touching the final test set. So then you have model comparison. So it split allows us to compare different algorithms fairly on the same unseen data. So this is what we were talking about, right? So you have a data set. The population of the data set might be 1 million, right? Out of 1 million, you are dividing into a training data and testing data. So testing data, you hold some data for testing. And inside training data, you again split the training data into validation and training. So you have this validation data. Why we need to have the validation data? Because out of the 1 million records, say for example, you take out 80. So for example, you take 80% of the data for training. Okay, in that 80%, you are talking about 60-20 ratio here. 60% you take the data, right? And you train the data, train the model with that 60%. You train the model, and then so once the model is trained, you use again 20% of the data which is there in the validation bucket to kind of see uh, however the data has model has performed during the training. So can we see how it is performing when you are giving the validation data, right? And finally you have a test data, which is like a final evaluation step, where you use around 20% of the data that you have, and you see and evaluate the accuracy of the model. Okay. So generally, if you see here, there is a visualization you can identify. So first is 80, around 80-20 split, and around in the 80 you have 60-20 split. That means usually the training data is a bigger chunk, which will go around 60 to 80%. It can range from 60 to 80%, and validation is more of 10 to 20%, and testing is also 10 to 20%. So here, this is the general practice to kind of use this population into this percentage training, validation, and testing. But there is again no thumb of rule that you have to choose the percentage in this way. So the percentage can vary depending on the quality of the data, volume of the data, use case of the data, etc. So the in short, like we split the data, so our model doesn't just memorize, but actually truly learns from the pattern that generalized to new unseen data. So that is the whole purpose of data split. So if you don't split the data, you will not be able to accurately evaluate the model performance, because it can like bias its the predictions, right, based on the it might memorize basically, right? That possibility is always there. So you, to make sure that your model is performing 100%, so you need to have this split, so that you get this uh, model performance evaluated accurately. Okay. So next we will talk about we talked about like 80%, 60%, 20%, 20% split, right? So how do we do that? Okay, so we are going one step back here, right? And to understand how this happens. So because you have 1 million records. In that 1 million records, we talked 60%, 20%, 20%. That's fair enough. But how to choose the data? You cannot simply choose the data randomly, right? So random choosing is one of the method here you can see, but there are other mechanisms that you choose the data, because choosing the data randomly for training, validation, and testing might again create issues when you're talking about the model accuracy. It can bias its predictions, right? So the choosing the sampling data is again a different techniques are there. So if you take what is sampling data, first of all, you're selecting a subset of a data from the larger data set. It's simple as that. You are so in the previous slide you talk there is available data. You are dividing into training, validation, and testing. So how you choose the data is what we're talking about, the sampling here. Okay. From the larger data or larger population, so that we can analyze the train and test without using the full data set. So that is simply what we are calling as a sampling data. So sampling data, there are different like random sampling is there, stratified sampling is there, cluster sampling. These three are important, and you have other different sampling mechanisms also. So but we will discuss this sample random sample, simple random sample, and stratified sample and cluster sample in this particular course or video. So first, let's discuss about the random sampling. So random sampling is means that each data points in the data set has an equal chance of being selected. So as the name says, it is random, right? It's commonly used when we want a smaller representative data set. For example, you want to randomly pick 1,000 customers from the database of 1 million. So you want to pick 1,000 from 1 million randomly. So it's just a random. Okay, there is no logic of picking here. So it's just a random. So you can specify that you want to pick the sample and you want to give the random state equal to 42, and you want to pick 5 customers here, right? It will just take the 5 random customers here. And one thing is to notice when we need to use this random sampling, right? So random sampling to be used, okay, uh, when you have a large data set, and like for example, when you have a big data set and you just need when to use random sampling, basically when you have a large data set and it is well mixed. That means when you have a big data set and you just need to have a smaller representative of that subset of the data. For example, taking 10,000 samples from 1 million customer transaction for a quick prototyping. So also depends on like classes. When you are having a classes are balanced, so you think the data or classes that are balanced. So in that case, you can comfortably pick the random data, right? So you can works best when all the classes, for example, churn, not churn, are roughly equal size. If that is a case in terms of customer churn or not churn, so the population is equal, almost balanced. So then you can, if the data set is imbalanced, so then you can go for the stratified or the next sampling. Or if not, you can use this random sampling. And there is no natural grouping in data. So in that case, you can choose a random sampling because there is no pattern, right? So a natural pattern to derive from. So then in that case, if your data doesn't have the cluster or any pattern, so you can you choose the random sampling. And this is also good when you're having a quick prototyping and testing. So you don't have time to do different types of sampling, applying your brain, because random sampling doesn't require much of an effort. So you can use it for quick prototyping. And also you can often choose it as a default choice when there is no special requirement exist. So that is what we call a baseline sampling method as well. So it is simple, but it has its own limitations, because if you have a fraud detection mechanism, if there is only 1% of fraud transactions are happening, but you're not able to pick that sampling based on that 1%, because that 1% might fit into that sampling or might not fit into that sampling, right? So when you're choosing that population, so you need to take those consideration as well of the fraudulent transaction that of 1%. So that also has to contribute for your training data and test data and validation data equally. So otherwise it will definitely bias your you will have a you will not have the unbiased like training data or whatever data you want to have, right? So that is where the major drawback of a random sampling, right? So if you choose that, so you should definitely you might possibly have that kind of data if the data is not equally distributed or equally having that similar pattern. Okay, so then choosing the random sampling might be a mess. It might create a lot of issues, right? So it's completely depend on if the data set has an imbalance, right? Like 90% non-churn and 10% churn, or 99% good transaction and only 1% fraudulent transaction. So then the random sampling might not work. So you might choose the another set of sampling, that is what we call it as a stratified sampling. So in stratified sampling, what might happen is this is simply stratified sampling ensures that the proportion of the classes or the group in the sample is same as the original data set. Okay, that means it chooses that population equally. It especially useful for classification problems with the imbalanced classes. So it makes sure that there is a enough representation from each kind of a data set that you have. So that is very important. It makes sure that enough representation. That means if there is a fraudulent transaction of 1% or if there is a non-churn of 10%, so all this should contribute to the sampling of the data. Otherwise, it can result in unbiased results. So that is why the representation is making sure here, okay, to kind of get that insights. So if you see the code here, right? So here it is making sure that you get churn based on different samples that you're having, and the distribution is equal distributed. That means whether it's the churn, non-churn, you are getting the population equally distributed in different classifications, like the data you are picking for the original data, training data, and test data. So in all of the class distribution or the data sampling that you are picking, the representation is in the equal proportion or the ratio. Okay, so that is the key thing here of a stratified sampling, that you're making sure there is enough representation for all variety of data that you are, especially for the features that you are targeting for the analysis, right? And when to choose a stratified sampling? A sampling is imbalanced classes. For example, in the fraud detection, only 1% of the transaction might be fraud, as we were discussing. And then in that case, stratified sampling ensures the fraud cases appears in both the training and test set. Okay, so that there is enough representation. And you can also helps maintain the class distribution across training and test sets. So that is the classification problem when you're talking about or targeting. So then definitely you have to choose the stratified sampling. And you have a small data sets. If the data set is small, random sampling might drop minority classes entirely. So stratified sampling prevent that. And you have use cases where you're talking about surveying and polling. So in that case, ensuring democratic subgroups, for example, age, gender, income, or proportionally represented. So, for example, these are the different the cases where you have to choose a like a stratified sampling. So this is not a random sampling. This is stratified sampling. When to choose the stratified sampling, right? And so if you talk about the thumb of rule, so you need to use the random sampling when data set is large and balanced, and you need to use the stratified sampling when data set is imbalanced or grouped by categories. So that is a thumb of rule. And stratified sampling, please note that word, the enough representation should be there for the classification of different variety of data in each category or sampling that you are making. Okay. So then finally, we'll move to something called as cluster sampling. So cluster sampling is nothing but instead of sampling the data individually or directly, you divide the population into different clusters or the groups. So then randomly select some clusters and take all the members or a sample of the members from those clusters. So, for example, this is pretty much useful when data is naturally grouped. For example, there is a school, there is a cities, there is a regions, departments. So these are very pretty much naturally grouped data. And collecting a true random sample from the entire population is difficult and expensive. Okay. For example, you want to understand the the student performance. Or example, you want to understand the in the election how much percent of the people might turn out for voting, right? Or you want to analyze the certain pattern of a population in terms of health, or you want to understand what exactly the prediction of the enough the population that you're targeting. Okay, for example, this is more of like a cluster sampling. For example, you want to perform certain emotional or sentiment analysis per each region. Suppose you have 28 regions, and out of these 28 regions you want to perform the prediction how much percentage of the people might turn out to vote in the election. So instead of choosing all the 28 regions and performing this kind of prediction or analysis, you might choose certain clusters or certain regions and then perform the analysis. And based on that, you can extrapolate that analysis to the other states. So that way, you are saving a lot of cost and time here. And that is a key thing, right? Because performing on the entire population might be expensive and time consuming. So that's why you are choosing the cluster here. And geographically, the data should be spread across. For example, selecting few cities, then surveying all household inside them. So when populating natural forms or groups, for example, schools, hospitals, factories, companies, cities, etc. And when complete population list is unavailable. So even in that case, it will be easier to access clusters than having individual records. So again, the thumb of rule here is use cluster sampling when data is naturally grouped and you cannot easily sample individual directly. And use stratified sampling if you want proportional representation of each group. So this is completely different. And using the cluster sampling can also be dangerous in certain cases where the cluster that you are choosing doesn't have the distributed or the diverse data, okay, inside it. So it should the cluster choosing is important. If the clusters are not enough distributed or diverse enough, so then the calculation that you are performing might go wrong. So in that case, the cluster you are choosing will play a critical play here in this case. So if you don't have that distributed data or diverse data in the clusters, so then cluster sampling technique might not work. Okay. So then finally, we will talk about one more model evaluation that is called as cross-validation. So cross-validation is a technique where the data set is split into multiple folds and the model is trained and tested multiple times on the data fold. Suppose you see here, there is a training data and test data, right? And the training data itself, you are folding it multiple times. That means you are splitting that into multiple permutation and combinations. So this is all about folding is a thing, but you are choosing the data in multiple permutation and combinations. So how do you do that? It depends on the types here. Okay. So the type that is most common type is k-fold, that is cross validation. The data is split in k equal parts, train on k minus one fold, test on one fold, and repeat into k times. So again, you have a stratified k-fold where same as k-fold, but it preserves the class proportion useful for classification with imbalanced types. So then you have a shuffle, again, different types, shuffle, shift, and nested, different types you have. So, but one thing is to note here, whenever there's a time series data you are having, right? So, and you cannot perform the k-fold blindly because the series of the event should be kept. Okay, because time series is more of a like bringing the data in order. Okay, if you are performing k-fold, the order of the data or the order of the event should not go on toss. Otherwise, that should be because it should be kept intact. Otherwise, it can result in ambiguous analysis because the events are performed in certain way. There is a sentiment, there is a reason for events to happen in the time series. So that needs to be retained when you are performing on the time series analysis. That is one of the key consideration you have to do when you are performing the cross validation using the time series data, right? And when to use this cross validation? So cross validations need to be performed when there is a small data set. Okay, again, this is not random sampling. When to use cross validation, right? So when we have a small data set, when data is limited, right? Using cross validation helps maximize the training and testing coverage because the data is less. So because you're performing permutation and combination, that will give a lot of um, possibility of lot of training of the data set that you can get. And you have model selection and comparison, compare multiple models, decision trees versus random forest, etc. And hyperparameter tuning, you can perform different hyperparameter tuning using this and prevent overfitting. So ensures model generalizes well, not just uh, to one lucky train split. Okay, because you're performing multiple combinations, so you are trying out different data sets here, so it prevents the overfitting because of that. Again, the rule of thumb here is use cross-validation when data set is small, median, and you want to reliable performance estimations. For huge data sets, a single train validation test split may be enough in most of the cases. And cross-validation may become expensive because of the huge volume of the data. And on top of that huge volume, again, you're performing the k-folds, etc. Then it would be a quite expensive operation to perform. Okay. So cross validation, please note that if it is very huge volume of data, like billions of records, so then you need to reconsider to use cross validation because it might be expensive. So finally, please like, comment, and subscribe to this channel and follow this playlist to get maximum out of this course. Hope this was useful. Thanks for watching.